Good evening, greetings and wishes. Welcome you all for the video lecture series on Explainable AI. Hope you are all doing fine and good. In this video, we are going to see about the next concept followed by the TCAV, that is concept activation vectors, how it is going to useful in explaining a concept. These all things in the last lecture we have demonstrated in a numerical based example. In today's class, we are going to see about another important concept that is called as concept whitening. What is meant by concept whitening and how it is going to solve the purpose and how it is gratefully helpful in predicting the predictions that we are going to see in today's lecture. Meanwhile, this lecture will cover you what basically all stuffs from fundamental level. So you no need to back refer any video for fundamental concepts since we are trying to demonstrate in a step-by-step manner. So I recommend all for viewers, you are watching the video to keenly uh, watch the video and know the basics, what is involved in the traditional method, how it is overcome by using this concept whitening, how it is overriding, and what is the major advantage of this concept whitening method. These all things we are going to see in today's lecture. So once again, I welcome you all for this video lecture series on explainable AI, and we are going to start with a new topic called concept whitening, that is called interpretable architectures. Under that banner, we are covering the topic concept whitening. So first we will go and these are the recaps. What is the necessity of concept-based explainability and how the logic is converted as an explainable terms. If you can able to recollect means just you can recollect. That is a particular concept we are explaining and make them as a predictable data, and based on the logic we are converting the particular explainable terms into a logic, and based on that we are completely explaining the scenario what we are interested in. This is the need of the concept based explainability technique. So what is meant by concept whitening means it is a intrinsic feature. It is a local level, not global. It is a local level interpretation only. But what is the thing what we are going to address here is, instead of doing batch normalization, we are just replacing that with the concept called concept whitening. So what is mean by this batch normalization and how it is going to help us? All these things we will see in the upcoming sessions. Okay, so um, first we will start with one convolutional neural network. What are the things available in convolutional neural network? You just reconsider that. First, a convolutional neural network consists of a input layer, okay, followed by hidden layers, and followed by activation layer, and followed by a output layer. We are just till now we are telling everything about input layer, activation layer, output layer, from input layer to output layer, output layer to input layer. We are adjusting the weights and we are re-verifying by adjusting the input values. We are adding one more concepts, everything we are doing. But we are not interested what is happening with the hidden layers. In hidden layer, what it is doing, which neurons are firing, which neurons are ideal. When we give the mixed level of concepts, which neurons get activated, actually what the neurons are actually gaining, these things we are not aware of. Still it is a hidden part only. Since that itself acts as a black box. In order to open that and make the neuron firing also, neuron dimensions also transparent, and any human being can understand, okay, this neuron has this weightage, this is actually recognizing this portion, this neuron is activated, so this is able to recognize this portion. Like that, if the neuron firing also get interpretable means, then it is very easy for us to go with the prediction. Okay, all are learning the perfect concept, so the prediction will be quite easy. In that basis, we are going to make out this concept pretty clear to the learners who are watching and who are learning. So concept whitening is a intrinsic level technique. So it is going to work with the hidden neurons, and based on the dimensions that related with the human defined concept. How we are defining the based on the neuron dimensions, that is which neuron is fired, this is related to the concept or not, what are the internal representations, these all things we are going to see in a step by step manner. Okay, so next thing what we are going to see here is, all right, so I think right, what is the concept whitening, we will check here. I think some 1 minute, let it be. All right, okay, this is disturbing. Okay, I will manage. Okay, so in a standard convolutional neural network, already I have explained, neurons in the hidden layers are fired based on the response of the mixture of the inputs and its features. So what I am trying to tell here is some of the diagrams also we are planning to draw, so that we will see in a one by one method. So I think the pen level is not matching. Okay, right, this slide. Okay, now so that if I touch open. So in a standard, sorry for the delay, I am just making myself comfortable. So one neuron might respond to blue color or round shape, sky texture simultaneously. Okay. So one neuron is looking three mixture of concepts. It is containing mixture of concept, blue color, round shape, sky texture. Three different things are combinedly present to one neuron. Then that neuron is realizing which portion, either color or round shape or sky texture, which portion or which pattern that neuron is actually responding. That is very difficult for us, since what happened, we are, I will take one pen. Okay, that will be different. So what I am trying to tell here is, if I consider one neuron, for that we are giving three different textures. One is blue color, okay, another one is round shape, and another one is sky texture. So it is going to, it gains different weights. So weight 1, weight 2, weight 3, and it will give some outputs also here. It will give some outputs also. But this weight, corresponding weight is this corresponding weight is due to which texture? It is looking blue color or round shape or sky texture. On what basis this neuron is fired? It is mixedly taking or giving highest importance to blue color or highest important once it sees round shape it is firing or giving the seeing the sky texture it is firing. On seeing the sky texture, neuron will gain some weights and it start to give outputs. So it is very difficult for us to interpret which portion actually the neuron is responding to. That is the thing what we are trying to make it as transparent. That is, make it as easy to interpret. We are going to make the difficult term into easily interpretable term. For that purpose only, this concept whitening is we are going to do. So the concept whitening is nothing but it replaces the batch normalization layers. what is meant by batch normalization? That is the main interest of today's scenario. So what is meant by batch normalization means, I will make it clear here. So once, okay, so, okay, now it is working fine. Select the pen. Pen highlighter. Okay, pen. Okay, right. So concept whitening means what means here we are talking about batch normalization, right? So what is meant by batch normalization means assume one classroom in which a teacher is asking to make the students to sit roll number wise. Okay. So for example, 1, next to 2, next to 3, next to 4. This is called as normalization. Normally, they are sitting in the particular thing. Next, same teacher is asking the students to sit in a random manner according to the interest. According to the interest of the. Some students are well versed in music, some students are well versed in dance, some students are well versed in um, yoga. So based on your interest, please rearrange yourself, like that one teacher is telling. So what the students will do, they will keep on rearranging themselves until the group gets settled. For example, they are making one group. That group is called G1. That group is completely comprises of music interested students. Another group is comprises of yoga interested students. That is called G2. And another group of students are interested in dance. That is G3. Like that, we are making specific groups. So on seeing the group itself, what we understand, we can able to identify G1 means music, G2 means yoga, G3 means dance. So if a particular group is called means, we can easily tell that this group is valid for highly worthable for doing dance performance. This G2 is highly worthable for making yoga. This group is highly worthable for making music, doing music levels. So this is called as what? Concept weight. Okay. So what we are making, each and every neuron, we are particularizing. We are particularizing. So what we are doing, we are going to rotate the datas. We are going to rotate the datas. Here the students are shuffling themselves. They will run here, run there, and just they will form one group. Until the formation of group is perfect, the class will be in a random manner. It will zigzagly, they will move in and around. Who are, hey, you are interested in music, hey, you are interested in dance, come together, like that they will form one groupism. Until the group is settled, the zigzagness or randomness will not get completed. Similar way, what is this concept whitening is doing is, it is going to rotate the data until it learn the particular things from the text inputs. So blue color, if we are assigning one weight, means the data will get rotated until it got settled in blue color. So now the neuron learns we have to look only the blue color. Next neuron, the data are rotated so that it will look only the round shape. Next neurons are rotated, then it will look only into the sky texture. So instead of assigning to only a particular neuron, we will reassign, we will rotate the data so that the data will be distributed among different neurons. That is called as what? Concept whitening. So in that manner only we are telling that C1, N1 will be fired. C2, N2 will be fired. C3, N3 will be fired. Like that we can able to understand, okay, I am giving a texture image. Then we will look which neuron is activated. N3 is activated means our concept is over. Okay, the model is looking into the texture. Then it will process correspondingly. It will do weight adjustments, activation layer, output will come. So no need to, then we can re-verify also, it will be perfect since we can able to understand in the layers itself. Okay. So this is the process of concept whitening method. So here we have mentioned that concept whitening perform orthogonal transformation. What is mean by orthogonal transformation? I am calling it as rotation. We are rotating the spaces until it is well cleared to the specific human defined concepts. So this is called as concept widening. Okay, some raw data are there. We will do rotation until we get the concept oriented with a particular neuron. This is called as the concept widening, what we are doing. Okay, so let us move into this. So the mathematical mechanism is the hidden activation layer is defined by Z of concept whitening, which is equal to R into Z minus mu by sigma. You know that Z minus mu by sigma is nothing but the batch normalization. It will take mean and then it will do standard deviation and it will take average, and this is the process of making the student sit in the number wise 1 2 3 4 5 6. There is some general normalization. But what is counter? We are going to, after making this sitting, the teacher is telling to rotate themselves according to the group. Just so we are doing the rotation. Can you able to understand the formula now? So the matrix R is learned such that the projection of the data on the ith axis maximizes the activation for images containing concept I. Until it recognizes, the rotation process will keep on rotating the raw data until the particular neuron learns the different set of things. So the particular data will be available each and every pixel information. So that particular data will be arrived in. Suppose the student, you can take the student example. First student is interested in music. Seventh student is also interested in music. So what it will do? It will rotate. First student will go. Second student again rotated. It is not interested. It will remove. Third student will come, remove. Fourth student will come, remove. Fifth student will come, remove. Sixth student will come, remove. Seventh student is coming means this weight will matches. This weight will matches means, and what happened? This will be grouped together. This is called as context whitening. After doing a thorough rotation, so after several iteration, we will come to the conclusion that same uniform patterns are grouped to a particular neurons. Okay, neuron 1 means this, you do this. Neuron 2 do this. Neuron 3 do this. Like that we will distributing the work to different neuron until the ith axis maximizes the activation for images containing concept I. Until it got recognition, until it is learning the weights properly, this rotation process keep on continuing. So this is the thing. Now I am going to make you to learn through a numerical walkthrough, that is autonomous driving risk. So we are equipping a system in the car. That car is going to activated with the autonomous driving risk indicator so that it will alert the driver. Okay, based on the condition of the road. This is the concept what we are going to take. So first the model sees a blurry image. Okay, so you can see two types of images here. One is a fog based road, another one is thick fog is there. So the hidden activations, that is passed through a what we are calling it as context whitening layer. We are giving it to the context whitening. So what context whitening will do, based on the example, rotation of matrix will takes place. So rotation of matrix is nothing but a filter only. If you give filter means it will filter into required. In Excel you can see now whichever is required we will tick mark so that data only will come. So that separate. Here we are having two types of data. Assume that we are having two types of data. One is called as texture information. Another one is called as edge information. What is mean by edge information and what is mean by texture information? You can see here. The clear road is nothing but textures, and the edge information means these two edges. Okay, back that is two ends of the road. So either it has to see two ends of the road, that is left and right side of the road, depending on the it is visible or not. Two edges of the roads are visible, and texture of the road means long view. This long view, it is visible, right? So this long view is visible or not. So the long view, we are calling it as texture. Left and right side of the road, we are calling it as edge information. So two information we are going to see. Either long view is clear for the driver, and two sides of the roads are visible for the driver. So it will check the long view as well as roads of the two sides of the road, whether any vehicles are standing in the left or if any vehicles are coming before the vehicle. These things, if I want to analyze, means I have to use the edge information. If I want to see the long view of the road, it is clear up to certain extent, means we can have a texture information. So any interpretation is possible. These are our human understanding only. You can imagine the patterns of the road also. Many stripes are available, that we are calling it as textures. That is what I am telling. Up to a certain limit, these textures are visible or not. And a certain limit, these two edges of the roads are visible or not. These things will make the driver alert. Okay, please slow down the vehicle. Please stop the vehicle. You are not seeing the information clear, like that. We can. This is autonomous driving risk. Okay, so unless the clearance came, the vehicle will not drive in the own pattern. So here I have mentioned what is the risk score and what is its meaning. Suppose if you calculate the risk score, the risk scores are normalized between 0 and 1. That is the important thing. It will settle down. We are rotating the values now. It will gain the value between 0 and 1. So until it gains the value, the rotation will take place. Suppose I am getting the risk score as 0.0, that is very safe. Sorry, 0.3 means low risk, 0.5 means medium risk, greater than or equal to zero point 0.7 means high risk, 1 means extremely danger. These are the risk score and its meaning for this interpretation. So this thresholding is trained based on the accident data. So several, if you consider one data set, means based on the accidental data, we are calculating and fixing this score. 0 means safe, very safe. 0.3 means low risk. You can go. 0.5 means medium risk, somewhat visible. Greater than or equal to 7. 0.7 means it is high risk, better to avoid driving or take a break and then drive. 1 means extreme danger, don't drive. Thick fog is there, nothing is visible. Somewhat visible means we can get high risk. Like the previous image, right? This is somewhat visible. You can see this car is coming. I am seeing from here. So this car is somewhat visible, but it is high risk. Since after this car, what is available? I don't know. It may be some passengers may stand here or some big rocks may fall down. That we are not, at least we are seeing only the lights. So this is high risk. This is safer. We can able to view the, but here it is not visible, even though you can go up to this extent. So this is safer. Like that, this neuron will learn up to the limit what is the different scenarios. Okay, so assume the model has two interpretable concepts. One is edge strength and another one is texture strength. So after concept whitening, this is very important. You can see here, after concept whitening, neuron 1 will learn about the edges. Neuron 1 will only, we are, after this, two concepts are selected, C1 and C2. So how many neurons? Two neurons will come. In the traditional method, there is no concepts. Direct input, one neuron will take the value, analyze and give the results. But here what we are doing, we are defining concepts. According to the scenario, how many concepts are coming into the picture, that we will define. So C1 is one concept used for defining edge strength. C2 is another one is responsible for edge concept, and neuron 2 is responsible for texture concept. This is what we are trying to coming to tell. So as per the, if there are five different concept, means we have to define five neurons. After concept whitening, neuron 1 will learn some level, neuron 2 will learn some level, neuron 3, neuron 4, neuron 5. Like that, we can define the concept. That is the advantage of concept whitening. Irrespective of the input data, we can add how many concept we want. That much data we can add in the interim also, so that suitable neurons will be assigned. Okay. So From concept label, the counter whitening will learn R is equal to point. Okay, 1 minute. I'll take the pen. Okay, so the concept whitening will learn this features. You can see here 0.9 minus 0.4, 0.4, 0.9. What is the meaning of this? Diagonal values you can check, that is equal. That means row 1 corresponds to edge axis and row 2 corresponds to texture axis. Row 1 0.9 gets the high weightage and minus 0.4 will be least. When rotating, what happened? This will come down. That is 0.4 becomes first element and 0.9 becomes second element. So the texture axis, the rotation, based on the rotation, the counter weighting is assigning this data. If 0.9 and minus 0.4 means it is edge, 0.4 and 0.9 means it is texture. Like that, counter weighting is assigning. 0.9 minus 0.4 is coming means neuron 1 will activate, neuron 2 will be silent. Reverse manner, 0.4 and 0.9 is coming means neuron 2 will activate, neuron 1 will be silent. So if you, in order to differentiate that, we are just keeping minus 0.4, less weightage, like that. Okay, so row 1 corresponds to edge axis and row 2 corresponds to texture axis. This is the meaning of this statement. Next, what we are going to do is, I am going to do the concept whitening approach in the what will happen. So concept whitening, what it will do means, 1 minute, here this. Okay, here you can see or into Z complement. That means R is nothing but 0.9 minus 0.4, 0.4, 0.9 into this Z complement means what? 0.5 into 0.3. 0.5 means, for understanding the edge axis, it gained the weights of 0.5. Any 0.5 information available? Yes. It understands the value of 0.5. On analyzing 0.4, it gains the weightage of 0.3. This is the two thing, the based on the complement it is understanding. This is rotational value. This is the information gained by the after counter whitening. What is the information the neurons are gaining? That is weight of the neuron we are getting from the after rotation. Based on the pixels, it is gaining the weight. Okay, this will concept whitening algorithm will architecture will do that automatically. We no need to discuss too much of thing. Complex mathematics no need. After seeing the rotation of data and based on the neuron row 1 and row 2 information, the neurons based on the dimension of the neuron, it automatically assigns the weight. Next, what it is doing, edge neuron 0.9, 0.5 minus 0.4 into 0.3, we will get 0.33. And texture neuron 0.4 into 0.5 plus 0.9 into 0.3, these things previous. 0.9 into 0.5 minus 0.4 into 0.3 plus 0.4 into 0.5 plus 0.9 into 0.3. Like that, two different things I am doing. So one is 0.33 and another one is 0.47. So raw activation is for what values? 2.5 and so this is the based on this we are getting 2.5 and 1.8. This is the actual weights of the neuron what it is gaining. So here what we are getting two values, one is 0.33 and another one is 0.47. Now based on the previous thing, 0.33 means low risk, 0.47 is also under medium risk only, right? Moderate, medium risk only. Now what I am doing, I have learned all these things based on the thing to raw activation will be 2.5 and neuron texture will be 1.8. These things, let it be. And what I am doing is risk is nothing but 1 minus learned values. So 0.7 plus 0.5. These are the two things where 0.7 and 0.5 are coming means. These are the, this is the counter weights computation. These weights are assigned by the computation algorithm. So 0.7 into 1 minus 0.33 plus 0.5 into 1 minus 0.47. So what is the value we will get? 0.469 into 0.265. Value will be 0.734, which is approximately equal to 0.74. So this 0.7, 0.5, you can replace this with 2.5 and 1.8 also. No issues. This is a random number only. Now, what is the dimension? Depending on the dimension, it will vary. Okay. So there is no such rules here. So this is just randomly we have assumed. If you want, you can better understanding. You can replace this with, if you want, you can, nothing will happen. If you replace this, you can replace this 0.7 by 2.5. Okay. And this 1.5 as, this 1.5 as 1.8. This is possible based on the previous data. That is no issues in that. Okay, 1.8. Where it is coming means from here. Activation 2.5 into 1.8. So 2.5 into 1 minus 0.33 plus 1.8 into 1 minus 0.44. The value will differ only. That's all. So remaining things are as it is. So as per this, if I do this computation means what happened? You will get a risk score of 0.74. So 0.74 means as per the rules, 0.7 means what? It's a high risk factor. High risk factor means only a part is visible, the normal driving is not suitable. That is, risk range is less than 0.4 means it is normal driving. 0.4 to 0.7 means we have to give a caution as per the system rules. So it is greater than 0.7. So what the system will, it will alert the driver, okay, this after this particular area you cannot drive normally, the focus is very poor, so you please make a alternate plan. Like that it will initiate the driver. Next, the system flags it as a dangerous condition, right? If road is clear, edge is 2.1 and the texture information is 1.9. You can see here instead of 0.33 and 0.47, now it is a clear road. Edge becomes strong. Texture also became very strong. So what we are doing, same computation, 0.7 into 1 minus 2.1 plus 0.5 into 1 minus 1.9. So you are getting minus 1.22. Minus 1.22 means we will make it as 0. 0 means what is the, what rules we have assigned? 0 means it is very safe to drive. We have mentioned it, very safe to drive. Traditional method will give only 0.74. So the backend information, there is no reason. Only it will tell very high risk. Why it is very high risk, we don't understand. But here we can understand why it is very high. Very high risk means the values how we are assigning and how we are getting the condition. So if I am calculating the risk score, the risk score parameter is greater than 0.7. So we are alerting this information to a driver like that. Okay, so based on this information, I can come to understand that a particular neurons are activated, risk source scores are calculated based on the different conditions. I am telling that this is a high risk. We are explaining. And similarly, if the road is clear condition means, similarly, we are analyzing the risk score. It is becoming 0. So based on the same neurons, I am telling that it is very safe. Traditional method don't explain about the risk. It will tell only there is a risk. That's all. But it may be or may not be. We don't know. Sometimes it may be wrong also. But based on the neuron information, if you analyze means we can able to get the information. Okay, it is checking the condition. Everything seems weak, so the neuron, the prediction is correct, so we can the system is very perfect, like that we can tell. So this is called as concept whitening plus linear risk model. We are taking the model name as linear risk model. The risk is high because edges and textures are weak. This is the reason. Okay, why I am getting the dangerous flag alert means the edges and the texture values are very weak. If it is very strong means it is okay. This is how the concept whitening technique is working. So this method we can compute and interpret the contributions which neuron is working on a particular level. So while getting the information itself, we can check the data. So all this information will come in the algorithm itself. C1 corresponds to edges, C2 corresponds to textures. C1 and C2 values are very moderate. So I am giving the value as a textures. Like that, it will explain each and everything. Only getting the single result, the value is high risk. Instead of that, some statements it will write. Neuron 1 activated, these values are weak, so I am the prediction is high. So as edges and the textures are very weak, I am telling that this there is a risk in driving the car, like that. So this is what the things about. This is called as concept whitening technique. So please understand the concept in a interpretable manner so that you can understand pretty clear. So hope this examples helps you well. Batch normalization, I tell, sitting or making the students sit in the row and then making the rotation to form a group. All these things will help you to know the concept about concept whitening in a better manner. Hope this